developers, but with another 1.5. The half is my apprentice. The application which I work on is called SwedAPL, and it values the liabilities of defined benefit pension funds. Like so many APL applications, it started off as the private work of a domain expert or a gentleman amateur, as an old-fashioned friend of mine calls it, and kind of grew from there. My role in the development is to act as a kind of technical expert and introduce new technology and help keep things moving. Fortunately, we don't have 1.7 million lines of code, but we do have quite a lot, and part of my brief is to introduce new technology in a way that doesn't frighten my colleagues, and which they can absorb and work with. Yeah. The context, what I'm going to show you, is that we have very long calculations, and they're very serial, and they're very repetitive. They're ideal candidates for parallelization, clearly. The work that I'm going to show you today was some very, very simple work done last year as a proof of concept. We're piloting the ideas to see what we could do. And as with all such projects, a key part of this is to see what we could get done with the minimum work, simplest possible coding. And the thing we chose to work on is a problem which calculates keyed sums from large tables, large in our world at any rate, going over 2 gigabytes. And in keeping with the low-tech character of the whole thing, as you see, I brought you a PDF to look at. Here's what's going on in our application. This lovely vertical arrow here is the main line of processing. We have a process here I've called value, which is doing the calculations. You can see it's going around in a little loop just there. When the valuation, as the valuation works, it throws out records onto a CSV file. And when it's all done, a process called sum summarizes the CSV table, does keyed sums from it, and replaces the CSV, which can go to over 2 gigabytes or more, with a small table which is under a megabyte, which the finished process inserts into a database. Very simple. And clearly the opportunity, oh look, this is what our CSV table looks like, for those of you who might not have looked inside one at any time recently. Ours has 2 columns. This is clearly encoded multiple keys, which we've just encoded into a single integer, and then a number in scientific notation to get the best accuracy we can. And there's nothing fancier going on with just summing these numbers. So this is what we thought we'd do. We thought, let's take the summarization out of the main line and have it happen on the side. In fact, in reality, with each loop, we have 4 such tables being written in parallel. Today, I'm just going to talk about one. But this is the same process, but somehow the CSV summing is being done on the side in a slave task. Master, slave. So the question arises, how do we communicate with this slave? How do we control it without the wonderful kind of technology and tools that Morten's been talking about? Any suggestions? Anybody had hands-on experience of trying to do something like this? Okay. Suggestions. What might you do? This is going to be a separate APL task. How could you talk to it?
Conga.
Conga, yeah, very good.
Or NI.
Quad NI, yeah.
You can use files.
Oh, you can use files, yeah. Okay.
Or you could just launch it with Quad CMD or whatever.
Yeah.
When you want it to run.
Yes. So we looked at different ways of talking to my slave. One of them simply involves giving it the file name on the command line, and it's got a latent expression, and it basically gets busy summarizing. And so we have no control channel on that. We just wait for it to finish. What I most wanted to do when I started on this was to use TCP/IP because that was going to be blindingly fast, and I can run my slave process anywhere in the world. I can be doing it on the moon. But when I started looking at that and the tools which I had for doing the communications, I saw that I had a lot of work to do to make that robust, particularly if I was going to put 2 gigabytes of data through that channel. I need to be doing checking to make sure that everything had been received. It stopped looking like a simple pilot project. APL+Win does have an OCX control for running a slave task. While I was quickly able to confirm that I really didn't want to pass all my data through it, it works just fine as a control channel. So here we are with the slave task doing the summing and the main task talking to it through the OCX. And although there's 2 OCXs in this picture, in reality there's only one. Mother told me never to cross the lines when drawing these diagrams. So if we were running the CSV only, without a control channel, this would be what would be going on. So in the master, we'd open the CSV file in shared mode, and we launch the slave, CSV sum. The slave will wake up, run its latent expression, read the file name from the command line, open the CSV in shared mode, and then as valuation proceeded here, the master appends the CSV in a loop, and the slave keeps reading it. So the CSV file is being used as a pipeline for the data. And eventually the master is going to write something at the bottom of the CSV file which will act as an end of file and will untie it. The slave reads whatever we put at the bottom to act as an end of file marker, and then waits until it's managed to get an exclusive tie, overwrites the CSV completely and unties it, while the master here is waiting on an exclusive tie, unties it, sends it off the SQL insert. So all fairly simple. But we can improve on that with a control channel. So what happens differently here is that we launch the CSV sum, the slave task, with through the OCX, and there's no latent expression on this side. It's just an active, clear workspace where we control everything from this side. These things are fun, aren't they? So we do we pass some instructions here to get the slave working. Now the slave knows what to do. Everything proceeds more or less as before until we get to this point where instead of writing something on the bottom of the file to act as an end of file marker, we set a flag over in the slave through the control channel to say we're finished now, we're all done. And the slave has been not just reading the file but also checking the finished flag. Now he knows it's finished, retie, exclusive, overwrite, untie. And the slave sets a flag to say he's all done. Now, according to my documentation, I should be able to do something much fancier with the OCX and raise an event over here. And this is done, but I never managed to actually get that working. So we do this explicit checking rather than waiting for an event here. Back on the master side, when we read the all done flag, we explicitly kill the slave and do our SQL insert. So not that much different, but in practice for the development and debugging, it looks a great deal better. And I hope to show you that in a moment. We've got hands-on control from the master task. That means that I can sit in my APL session and drive stuff inside the slave. But it also means that I can, while debugging, I make the slave task visible. I can go in and ask questions in the slave session. Because the slave is not working from a latent expression, it makes it easy for me to write multifunction slaves. I can put them, give them all kinds of capability in the workspace and just load them up. Setup's fairly light, debugging's fairly easy, and we get the Scandinois feature. We get murder, not suicide. What do I mean by this? When the slave task is finished, the master kills it. So the termination of the slave task is under the control of the master process. If I don't do that, if I don't have the control channel, the slave task has to just cut its own throat when it finishes and say, I'm dead. There's no way without the control channel to know what the status of the slave is. And because the operating system will kill the slave if the master dies, this process using the control channel leaves no orphans for me to clean up. If the master dies, that is. So let's see if I can show you this. So here's the master task. Events. And very good. I'm going to write a big CSV file. Not too big, we don't have a lot of time. And I'm going to put it there. Let's open up an Explorer window so we can watch that. And we'll put you up in the right-hand corner. And that's an old one. Let me get rid of it to start with. Very good. So the name of the new CSV file is Big Foo. I don't know how I think of these things. The name of the slave is slave. And as you see in the Explorer window, we've just created that file. It's empty. And we're now created a new OCX. So at the moment, the slave task exists, but we can't see it anywhere. If I look down on my taskbar, I see no sign of it. But I'm going to set its visible flag, which is not something we do in production, but just between us. And it pops into view there. Quite nice. It's an empty workspace. And I can get into its session window. As the conjurers say, nothing up my sleeve. Now back in the master, I tell it to load my CSV sum workspace. And I have some functions, even some variables. My debug variable is a flag saved as off in the workspace. But if I turn it on, the slave is going to produce a trace, a log in the in its own session, which will be helpful to us. So I'll turn it on. There it is. Debug's on. Back in the master, set the finished flag as false. Tell it what its name is, and here is where I tell it what to do. Basically, telling it what to do is sum the file name. And in my own session, I note that I've launched this. I note that I've launched the slave. Now I'm going to simulate valuation. I've got a big table here, lots of stuff. I'm just going to write it out to the file. And you notice as soon as I did that, the slave, which is sitting on the loop, picked up the records and started summing them. And it's now got keys and values. No, it doesn't. It has sums. That's what it has. There we go. So back here in the master, we'll continue with the valuation until we've written about 10 megabytes. I'm just going to let that run through the loop. This is even more fun when you've got 4 of the slaves running simultaneously. Good. So now the CSV is about 10 megabytes. And we can't see that in Explorer for some reason.
You could have 5 too.
Yeah, I'd have thought that too. Let's try that. But it didn't work this morning either when I tried it. However, if I just go out and in again, it still doesn't work. Well, I don't like Windows either.
You untie it.
Yeah, I think I will. Stuff works. Yeah. Now I'll untie the file, and I'm getting ready to tell the slave to finish. I set the finish flag and the slave jumps into action, and you can see here it says, yes, I replaced the file. And now I go into a wait loop in the master, which didn't have to wait very long at all, because it's found that the slave has finished, and it can now close and delete the slave. The slave will normally die silently, but because I've given it a session, it asks for permission to die. Very polite. If I bring back the file, yes, it's down to 413K. Magic trick. So that was pretty simple. But we managed to get the thing working and established it's fairly reliable. Our next step is we're going to put this into the production code with a fallback where the master takes the CSV file and sums it if the slave isn't signaling that it's alive and finished its work. So, Kai.
I don't speak Danish. Does it mean now shall we see?
Yeah, you do speak Danish. And if the mechanism proves reliable through our next product cycle release, then we've got a much bigger agenda for it, to putting out large parts of the valuation task into slave tasks, and hoping to get more use out of our custom multiple cores. Yeah.
But you're limited to one machine, one computer.
Yes.
You also have this
all
object control.
That's why I'd much rather be running under TCP/IP. Yeah. Thoughts, comments, questions?
When you're committing there, between the slave, are you sending the command to the slave saying, quad off, kill yourself, or are you telling the slave to run the function?
Good question. Actually, neither of those. I just close and delete the OCX object, and the operating system kills the task.
To the OCX.
Hmm.
You said if the master dies, because the OCX is connected to the master, it also dies with it.
Yes. Yeah. And that's the bit that's particularly worth having, because if you've worked with, say, Excel instances, you know how easy it is to wind up with orphaned instances floating around.
I got one home in Germany. He was looking for a suicide note. The slave sees suicide note.
Right. Yeah. But, yeah. It's an issue which has to be solved.
It's difficult to you want the master when it dies to automatically kill off the slave.
Yeah.
You won't get that from the TCP/IP.
No. So,
It's unclear to me, do you wait until the first CSV file is finished, so to say, before you make the sums, or do you make the sums in the run as the first CSV file is filling up?
well, that's absolutely the key question. At the moment, without this installed in the production system, we wait for the entire file to be written.
That's a waste of time.
Yes,
Okay.
absolutely. And it wastes significant time. Summing a 2 gigabyte CSV file takes typically 90 seconds, perceptible delay. This way, when we send the finish, there's almost no delay whatsoever. So we save about 90 seconds on each loop of a very long valuation. I think we're done.
You don't?
Oh.
From the title of your talk, I was expecting to see a presentation of some tool that I think APL 2000 provides, some kind of tasks manager, scheduler. Are you aware of that, or is it a figment of my imagination?
I'm not aware of it, so I can't. Sorry, you can't hit the back.
Sorry. Yeah, from the title of the talk, I was expecting to see a presentation about, I think there's a tool that APL 2000 provide to do task scheduling. But is anybody familiar with that? No. Okay. All right. Well, I'll sit down again then. I think they have some kind of tool, but I think they charge extra for it.
I'm glad you mentioned that, because that's been an issue for us with some of the tools on their tool set. Yeah.
You mentioned the timing gain in performance.
you have done tests on how well it performs without the slave task, and how, I'm just thinking in terms of the serialization and parsing of the CSV file. Is that significant at all in this link between master and slave?
The serialization and parsing of the CSV file. It's the same whether we use the slave or not. It's only a question of where we're doing it.
Well, my question is, if you were to summarize your table without writing it to a temporary CSV file,
yes,
compared to serializing it, writing it to file, let the slave task parse, process, and then create the end result. How do those two compare?
I haven't done that comparison, right? But it's a good question. It had occurred to me too.
Okay.
Okay.
Thank you, Stephen. If it's too busy in the canteen, I guess we could sit here and waste a few minutes. But I guess we'll take lunch break now as per the program. And we can leave in this room. Can we leave things here?
Sorry?
Can we leave our computers here? Is it set? Okay. Well, thank you.
Yeah, but you can go to the canteen. There should be some tables reserved for us to sit in the back corner here. And that's just a buffet. I hope you will enjoy.
No.